I'm going to work a homework problem from trig graphing number 2, and what I'm trying to do here is tie note cards 10 through 14 together. The note cards that we talked about, 12, 13, and 14, we had the vertical stretch, the vertical shift, and the horizontal shift, or the vertical shrink. We did those all individually, but it's not always going to come like that. You're going to have to do you have to do them all together. And so I want to do a homework problem with you so you can kind of understand this. The first thing let me say is this. You do not have to have graphing paper. If you can get some graphing paper, if you know someone that has some, or if you can go buy some, I recommend you doing that. Otherwise, you don't have to. You can make it on your own. Because I've got graph paper here, but I'm going to show you how to set this problem up. So let's get started. The problem I'm going to do is number 2 from trig graphing 2 rather. It's y equals 3 sine parentheses pi, or I'm sorry, x plus pi halves. Now, what you should be able to tell right now is you have a horizontal shift inside this parentheses. I'm going to go left pi halves units. And I have a vertical stretch by a factor of 3. And the way that I want to do this is I want to do it just like I would do order of operations. I have to do it in a particular order. I want to start inside the parentheses just like I would with PEMDAS, and then I want to do my multiplication next. Okay? Now, what I'm about to write is not on this problem, but if I had some plus or minus d units out here for a vertical shift up or down, that would be last, okay? Because you would do parentheses first, multiplication, and then you're adding or subtracting last, okay? Just in case you run across something like that, and you will. All right, so the first thing we have to do is we have to set up our graph. So I would draw an xy plane, or x theta plane, or y theta, excuse me. And after you do a few of these, you'll get better at doing it, and it won't be near as difficult to do. Okay, so we have to remember how to graph my sine curve, okay? Because I'm dealing with sine. I have to start off with my sine curve. That means my period is going to be 2 pi, just like the note card tells you. My period is 2 pi. And I want to split this up into increments of pi halves as my note card shows. So I'll start at 0, 0 there. And then here I'll go ahead and I'll make this pi halves. Then pi. Then 3 pi halves. Then 2 pi. Now if you're wondering how I know how to do that, it's like this. If I have 1/2 pi here, 1/2 pi, 2/2 pi, 3/2 pi, and 4/2 pi, or 4 pi halves. Look, my denominator is 2, right? 1, 2, 3, 4. Well, we know that 2 over 2 is 1 pi. And we know that 4 over 2 is 2 pi. That's how those are the skills you'll be using to count these increments. Okay, now I'm going to need some negative values because I can see up there in my problem that I'm going to have the horizontal left pi halves units. So I'm going to go ahead and create some pi halves units over here. So if this is pi halves, this is negative pi halves. If this is pi, and this is negative pi, and so forth, okay? And then this will be 1, 2, 3, 4, and so on. You get the idea. Now remember, the period of the sine curve, the regular sine curve we start with, is 2 pi, and the range is from -1 to 1. So the first thing that I have to do is sketch my sine curve. And it starts at 0, 0, and it goes up to this point pi halves comma 1, and then back down through the x-intercept pi, and then down to this point 3 halves pi comma negative 1, and then back up to 2 pi comma 0. Now my sketch is a little not very smooth right there, but it's not very easy to draw with this tablet, so that's the best I have right now. But this is the parent that I'm starting with, and I have to start here every time. And I have to remember these critical points. Every intercept and every minimum and maximum value. So those points are the critical points that I'm going to shift. Now again, what I set up here is that I have a left shift of pi halves, and I'm going to go in this order: left, pi halves. Then I've got this 3 out here, and how I do that, if you remember, is I need to multiply the y values by 3. So here's how this works. What you could do is you could take each point and do one transformation at a time and then trace that curve. So in other words, I could take each point and go left pi halves, 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 and then trace that curve out in a different color, and then do each one after that. What I recommend you doing, something I think you'll find a little bit easier, is take each point and do every transformation you've got in order. So this point, I've got to go left pi halves, then I have to multiply the y value of where I'm at times 3. Well, the y value here is 0, so times 3 is 0, so that point stays here. Now I'm at this point. I have to go left pi halves, which places me here. Then I have to multiply the y value by 3. The y value here is 1. 1 times 3 is 3. That puts me up here. Now I'm here. Left pi halves puts me to here. The y value is 0. So 0 times 3 is 0. That point stays there. I'm at this point now. Left pi halves takes me to here. Multiply the y value times 3. The y value here is negative 1. Negative 1 times 3 is negative 3, which takes me to here. And my last point, left pi halves, the y value is 0, so 0 times 3 is 0, so that point stays here. And remembering the basic shape of my sine curve, I just kind of trace it out with those points. And that is this yellow or green, whichever color this is. This is this function here. 3 times the sine of x plus pi halves. And that's how you would graph that by hand. You would start with the parent and then undergo the transformations. Now I want to add something to this. This is the answer to number 2 on your homework. But I just want to take the time for a second. What if there would have been minus 2 out here? If there would have been minus 2 out here, then I would have done the same thing. Starting with this point, changing my color here, it's in red. I would have gone left pi halves, multiply the y value by 3, and then down 2. That would have went to here. Would have gone to here. Okay? And so here again, left pi halves times 3, the y value times 3 here, but then down 2 units, that point would go to here. Left pi halves, y value times 3 stays here, but down 2 units. It's important that you go in this order: parentheses, then your multiplication, and then your adding or subtracting. Or in other words, horizontal shift, vertical shrink or stretch, even the reflection if you have a negative value out there. If there's negative out here, it's a reflection. And then this is last out here. Left pi halves, y value times negative 3 takes me to here, then down 2. Left pi halves, y value times 3 stays here, down 2. And then I would trace it out. And the red would be how it would look if I had the original problem plus the vertical shift negative 2 units. But that's how you do all of these, even if it were cosine. you start with that basic cosine or sine curve on the period 0 to 2 pi. And then you have to make your little, well, first you have to make your little xy plane here, or y theta plane, and you just sketch which curve you're working with. Make sure you concentrate on those critical points and then undergo each transformation, and I hope you'll find these not too difficult.